Alright, today we are going to do the chapter on atoms and molecules. Alright, before we come to what is a molecule, we are going to first look into this law of conservation of mass. This law of conservation of mass states that mass can neither be created, alright, it can never be created nor it can be destroyed in a chemical reaction. We are going to look this by means of an experiment, that how can mass be never created nor destroyed. Now in this chemical reaction, we have taken a conical flask, right, and there is a ignition tube. In this conical flask, we have taken some solution of silver nitrate, and there is concentrated hydrochloric acid kept in the ignition tube. After this, we have taken the measurement, that is, we have taken the mass by a physical balance of the entire setup. Now, the next step is that we add this hydrochloric acid to silver nitrate. The moment we add it, after some, there's going to be a chemical reaction and silver chloride is going to be formed. We can understand that by seeing that there is a white precipitate forming in this solution. White precipitate means there's going to be a kind of a small white color sticky substance seem to be coming out from it, from the solution. This is silver chloride which is being formed. After the reaction has taken place, again we take the mass of the conical flask of the entire setup. We will find that there is no change in the mass. Before the reaction also it was the same, after the reaction also is the same. Alright, so this shows that this law of conservation of mass, that is, the mass can neither be created nor destroyed. It will remain the same in a chemical reaction. Now, the next law which we are going to see is the law of constant proportion. Now, when there is a pure chemical substance, in any pure chemical substance, the chemicals, the elements are always present in a definite proportion by mass. We are going to look here with the help of an example how this is so. First of all, we are going to burn a magnesium ribbon. There is an example here of a magnesium reacting with oxygen. Magnesium ribbon, when it burns in oxygen, we get magnesium oxide. Then we see a second reaction where magnesium carbonate is strongly heated to give magnesium oxide and carbon dioxide. And the third reaction where magnesium nitrate is taken and heated, we get magnesium oxide, nitrogen dioxide and oxygen. In each case of magnesium oxide, there are only two elements, that is magnesium and oxygen. So the same elements are always present, magnesium and oxygen. In magnesium oxide, we will have only two elements, magnesium and oxygen in every case. Alright, the ratio of magnesium to oxygen will be 3:2. Then we are going to look into what is Dalton's atomic theory. Dalton's atomic theory said that matter, all of us know what is matter by now, it consists of very small particles, alright, and he called these particles as atoms. Whether it is a solid, liquid or gas, matter always consists of atoms. Now here we are going to look at two elements, alright, one is iron and one is carbon. In iron, alright, we will find that if iron is made up of many atoms of iron. Alright, we have a bar of iron and a bar of carbon here. Say this, in this iron, alright, a piece of iron, there are many atoms of carbon. And all these atoms of iron are alike in all respects. One atom will not be different from the other. In carbon also, all the atoms of carbon will be similar to each other. But when we compare the atoms of iron and carbon, we will find that they are going to be different in all respects from each other. Iron atoms will be different from carbon atoms. Now, this atoms of different elements, they combine in small whole numbers to form compound. For example, here we have got atoms of hydrogen 2 atoms of hydrogen combine with 1 atom of oxygen to form a molecule of water. So this is from number 4. Now, atom is the smallest unit of matter which takes part in a chemical reaction. Whenever we have any chemical reaction, we have seen when we talk about magnesium reacting with oxygen, actually in the magnesium atom reacts with an oxygen atom. All right, oxygen, these magnesium and oxygen is the atomic forms which takes part in the atoms which takes part in a chemical reaction. All right, so here atom is the smallest unit of matter which takes part in a chemical reaction. So when there is an element, it is actually the atom which takes part in the chemical reaction. Now, atoms can neither be created nor destroyed in a chemical reaction. The number and the kind of atoms in a molecules in a given compound are fixed. For example, in a molecule of water, right, the atoms of hydrogen, that is 2 atoms and 1 atom of oxygen, are always fixed. Then atoms of some elements can combine in more than one ratio to form 2 or more compounds. Let us look into what is this what is an atom? Definition of what is an atom. Atom is nothing but it is the smallest unit of an element. For example, if I have a jar of oxygen, the smallest unit is the atom. All right, any element, for example, here I have shown you that iron and carbon, the smallest unit will be an atom. So the atom is the smallest unit of an element. It can exist independently or may not exist independently. For example, iron atom can exist independently, but oxygen atom usually combines with another oxygen atom to form a molecule of oxygen. An atom always takes part in a chemical reaction. The size of an atom is very, very small. It is measured in nanometers. 1 nanometer is equal to 10 to the power of minus 9 meters. Now, when we look at what is atomic mass unit, now the smallest element is hydrogen, and the mass of 1 atom of hydrogen is 1.673 into 10 to the power of minus 24 gram. This is the mass of 1 atom of copper. Now, all these quantities, all right, these above masses, they are not convenient to use for any calculation. So, since hydrogen is the lightest element, the mass of 1 atom of hydrogen is taken to be as the 1 atomic mass unit. But there is a drawback in using this because hydrogen has got 3 isotopes with atomic masses 1 AMU, 2 MU and 3 AMU. So you use 12 carbon as the new isotope for atomic mass unit. Why do we use this 12 carbon atom is that? Because the atomic mass of 12 carbon isotope of carbon is a whole number, that is equals to 12. And thus 1/12 of 12 carbon is equivalent to 1 atomic mass unit. So all the atomic masses are compared with 1/12 of 12 carbon. Now there is a modern definition of atomic mass unit, that is the mass of 1/12 part of 12 carbon is equivalent to 1 atomic mass unit. All right, and there is a modern definition of atomic mass of an element, that is from the text here. That is the number of times an element of an element, that is the atom of an element, is heavier than 1/12 of 12 carbon isotope of carbon is the atomic mass of the element. So how much number of times that atom of an element is heavier than 1/12 of the 12 carbon isotope of carbon, that is the atomic mass of the element. And gram atomic mass of an element is the atomic mass of an element expressed in grams. For example, if the atomic mass of magnesium is 24 atomic mass unit, then gram atomic mass of magnesium is 24 grams.